What's up? Welcome to another video. In this video, I'm going to be talking about exponents or indices. You can write the product of identical entities or large numbers in a very short form called the exponential form, or you can call it the index form. Take for instance, you're trying to write 8 multiplied by 8 multiplied by 8 in a very short form. This can be written as 8 and a superscript of 3. Similarly, if you have to multiply 1/2 in 2 places, this can be written as 1/2 and a superscript of 2. Let's say you're trying to multiply a n number of times. Then it translates to a and a superscript of n. This superscript is what we refer to as the exponent or the index, while a is referred to as the base, and everything all together is a power. Now, 2 as a base and 3 as an exponent, altogether, this is a power. But while you're trying to pronounce this, you still refer to it as 2 raised to the power of 3. But dealing with each of the terms you have in that system, then you refer to 2 as a base, then you refer to 3 as an exponent or an index. You can always write from the index form or the exponential form to the expanded form. Say you have 2 raised to the power of 3, it means that you're multiplying 2 by itself 3 times. Let's say you have a negative 2 raised to the power of 3, it means you are multiplying negative 2 by itself twice. But if you have a negative 2 raised to the power of 3 with a negative not inside the parentheses, then this means you have a negative 2 times 2 times 2. Now to the laws of exponents. When you have to multiply 2 powers with the same base, have a common base, the rule says all you have to do is to add the exponents. This is equal to 7 to the power of 5. The explanation to that is 7 raised to the power of 2 means 7 by itself 2 times, while this means 7 by itself 3 times. And so this equals 7 raised to the power of 5. So instead of writing it in a continually expanding form, we can just add up the powers. So therefore, we can write it in a more standardized form that a, which is the base, then an exponent of m multiplied by a, an exponent of n equals, since they have a common base, you have a, then you have an exponent of m plus n being added up. Similarly, if you have to divide, if there is a division, take for instance, you have 7 raised to the power of 3 divided by 7 raised to the power of 2. Everyone knows this can be written as 7 to the power of 3 over 7 to the power of 2. If you write this in expanded form, we have 7 in 3 places over 7 in 2 places. 7 divided 7, 7 divided 7, and we are left with 7, which is synonymous to 7 to the power of 1. Then, rather than writing it in an expanded form, we can write this as 7 to the power of 3 minus 2. This equals 7 to the power of 1, which means that we can place this as a raised to the power of m divided by a raised to the power of n equals a m minus n. Moving forward. And now you can also have what you call the power of powers. That's when you're trying to raise a power to another power. For instance, if you have 4 raised to the power of 2 raised to the power of 3. But this means you are taking 4 to the power of 2 to multiply itself 3 times. And when you add this up, using the first law, we have 4 raised to the power of 2 plus 2 plus 2, adding up the exponent, and this equals to 4 raised to the power of 6. So we can see that basically what we eventually did here was just a repetitive addition, which is the same as multiplication. So we can rather have 4, then multiply the two exponents. 4 raised to the power of 2 times 6, which is equal to 4, or 2 times 3, which is equal to 4 raised to the power of 6. And so if we have to put that into a standard form, we're going to have a raised to the power of m raised to the power of n equals a raised to the power of m multiplied by n, which is a m n. Also, you can have to raise a product to a power. Take for instance, you have 3 multiplied by 4 raised to the power of 3. This can be written as 3 raised to the power of 3 multiplied by 4 raised to the power of 3. That is, this exponent affects each of the base that you have in the parentheses. Similarly, if you have a quotient, that is, if I want to write it in a more generalized form, a multiplied by b raised to the power of n can be written as a raised to the power of n times b raised to the power of n, and you can put them side by side as a raised to the power of n, b raised to the power of n. Similarly, if you have a quotient, that is, you have 3 over 4 all raised to the power of 3, you can write this as 3 to the power of 3 over 4 to the power of 3. And in the more generalized form, a over b raised to the power of n or m or anything equals a raised to the power of n over b raised to the power of n. Let's talk about zero exponent. When you take a number and then you raise it to the power of 0, say 5 raised to the power of 0, you will have 1. And this applies to all the cases except for 0. That is, when you take a and then you raise that to the power of 0, your answer will always be 1, with the exception of 0. That is, if you have 0 raised to the power of 0, it is undefined. The explanation to that is this. Let's go back to 5. Let's say you have 5 raised to the power of 3, and then you're trying to divide that by 5 raised to the power of 3, which are basically the same thing. So these, according to the law of indices, should be 5 raised to the power of 3 minus 3, which is 5 raised to the power of 0. Okay? Or we can say 5 to the power of 3 divided by 5 to the power of 3, which we can write by expansion as 5 in 3 places over 5 in 3 places. And when you try to divide each of those values, the answer is going to be 1. So which means 5 to the power of 0 equals 1. And this is applicable to all the cases that you can have where you're taking a variable and then you're raising it to the power of 0. Don't forget that there is an exception to this rule, and the exception is a must not be equal to 0. Let's talk about negative exponent. When you have 2 raised to the power of 1, this can be written in form of fraction as 1 over 2. If you have 3 raised to the power of negative 2, this will be written as 1 over 3 raised to the power of 2. So by the time you are taking the inverse of this 3, which is 1 over 3, the negativity disappears because it is now in form of fraction. Now we can say that generally a raised to the power of negative m equals 1 over a raised to the power of m. What explanation do we have for this? So let's say we are trying to divide 5 raised to the power of 2 by 5 raised to the power of 3. So we're going to do this in two forms. We're going to divide it directly to give us an answer in form of fraction, and we're also going to do it in index form. So we're just going to take the fraction part here, and the index part here. So the fraction part basically is just taking 5 times 5, which is 5 raised to the power of 2, and 5 times 5 times 5, which is 5 raised to the power of 3. This equals 1 over 5. Dealing with the index, by the law of indices, 5 raised to the power of 2 divided by 5 raised to the power of 3 means 5 raised to the power of 2 minus 3. Subtract the index. That's equal to 5 raised to the power of -1. So, which means what you have on the left hand side and what you have on the right hand side are basically the same thing. So, we can say by translation that 1 over 5 is equal to 5 raised to the power of -1. Let's look at the application of some of the laws that we've learned. First, we are taking k to the power of 4 to multiply k to the power of -7. Now that it has been established that they have a common base, and we are multiplying, then you have to add the exponent, k raised to the power of 4 plus -7. So this equals k to the power of 4, positive, negative, that's negative. So we have k to the power of -3, which can also simplifies or can be rewritten as 1 over k to the power of 3. As we've said, that the negative means you are taking the inverse of the base as well as the exponent. This equals to c raised to the power of 9, this is division, minus 5. So this equals c raised to the power of 4. Here we have the power of powers. So all you have to do here is to multiply the power. B raised to the power of 4 multiplied by 5. This is b raised to the power of 20. Here we have a power of product. So this becomes 3 raised to the power of 3, x raised to the power of 3. 3 raised to the power of 3, basically, if you decide to take it a step further, it's going to be 27. That is 3 times 3 times 3, and x raised to the power of 3. Next, this is a quotient of power. A power of quotient. Sorry about that. So that's going to be x raised to the power of 5 and 2 raised to the power of 5. This equals x raised to the power of 5. 2 raised to the power of 5 equals 32. Lastly, we still have a product, but this time around the power is in form of a fraction. So 1 over 3 plus 5 over 3. This equals a. 1 plus 5 is 6, and this is divided by 3. This equals a raised to the power of 2.